I just finished grading these final exams, and it turns out that the average score for women was 9 points higher than for men. Was that a fluke, or did the women really know the material better? Despite the fact that we're dealing with two distinct populations here, men and women, we can answer that type of question with statistical inference methods similar to those we've already learned. In this program, we'll learn how to analyze two sample problems with a new T procedure. We'll see how to calculate a confidence interval for the difference between two means. And we'll use a two-sample significance test to see whether two populations have different means. In the last program, we took a big step in our ability to do statistical inference. We learned about T procedures, which work when we don't know the population standard deviation. We also learned about paired comparisons, for example, before and after studies. But quite often, studies compare two different groups, like the men and women in my class. With a little intelligent tinkering, we can make the concepts we've already learned work for situations like this. That's nice because they crop up all the time. For instance, two sample studies helped reform one of the federal government's most disputed programs.
A year ago, times were hard for Jan Mooney. With 2 children to raise, no husband, little education, and minimal job skills, she turned to welfare for help. It was her last resort.
To me, it feels degrading. I mean, I did not enjoy it at all. I walked around depressed all the time because it's kind of like, and towards the end of the month, that last week will kill you. I mean, really, you run out of food, you know, I mean, it's terrible.
She wanted a job. Welfare gave her money, but no way to escape dependency on the state. Fortunately, Jan lives in Baltimore, a city experimenting with a program designed to turn welfare from a trap to an opportunity. The program is called Options.
The reason why we do resumes first is if you do resume first...
Everybody's trying to better themselves. Everybody wants to improve. Everybody runs into hard times at one time or another. You know, it's just that there wasn't anyone around all the time to try to help you, to try to enhance your ability to want to get off of public assistance.
Al Truesdale leads a team of teachers and counselors who offer courses such as remedial English and math,
$5.50. No, that's incorrect.
hands-on vocational training and basic skills assessment,
Okay, your time is up. I got the 20.
and a level of personal attention not possible in the standard welfare system.
Okay, and how much is your food stamp grant?
We try to make sure that the clients, when they come in, get as much support as we possibly can, so that if a problem comes up in the training program, in the school, or on the job, we will be somewhere around that we can help them with their problem, or they can get in touch with us.
Never, ever, ever answer
The Options program seemed to be an improvement on the existing Welfare Jobs program, a program called WIN. But only a statistically sound experiment could determine if options was making a real impact.
Hi, Celeste. Did that printout get here?
The experiment was designed by Daniel Friedlander of the Manpower Research Demonstration Corporation. He began by randomly assigning women to either the options program or the WIN program.
The experiment starts out by finding two groups that are as similar as you can possibly make them. And the idea of creating those groups and by a random draw is what makes them similar. And it's the fundamental idea behind an experimental control comparison.
The experiment's main goal was to see whether women who went through options earned more money after 3 years than clients who went through the WIN program.
You could take a pocket calculator and just find the average earnings for the experimental group, find the average for controls, subtract the two, and the result is the impact of the options program. Once you've done that, though, the question is how certain can you be that that's a true effect and not just the product of chance, of random events happening to these two groups. So you need a statistical test to help you rule out those chance factors. And in this case, we used the two-tailed t-test to compare the average earnings for the experimental group with the average earnings for the control group.
A t-test was essential in the study because the underlying population standard deviation was unknown. After gathering data for 3 years, a t-test on the mean incomes of the two groups showed encouraging results.
The principal finding from the experiment was that the options program was successful in increasing the earnings of the eligible population. Those earnings rose over a 3-year period by a little bit more than $1,000 per experimental on average.
The results were clear. Giving women more intensive services allowed them to earn more money and help them get off welfare. The results were also timely. Congress was embroiled in debate over how to reform the welfare system. The positive results from Baltimore and other experiments helped reform-minded lawmakers push through the first major overhaul of welfare since it was started in 1935. The overhaul included such ideas as increased daycare, mandatory attendance, and remedial education, ideas shown to work in the options program. Such services helped Jan Mooney get off welfare. After attending classes at Options and working with a job counselor there, she landed a full-time job as a security guard. The job offers room to advance, and though she won't get rich on the pay, it beats the monthly welfare check she had been getting.
They gave us $3.95 a month. So now through this job, my income is $612 a month. So that's a big difference. Since I've had this job, I've really been reading into like law enforcement. I love my job. And I love being out working, and I don't think I'll ever stop now.
The options experiment compared two distinct groups: people assigned to the existing welfare jobs program and participants in the options program. Let's make a table of the pertinent information from the two samples. For the traditional welfare program, N1, the number of participants, was 1,395. X bar 1, their mean total earnings over 3 years, was $6,595, and the standard deviation, S1, was $247. There were slightly fewer people in the options group, 1,362. Their X bar was $7,638, with a standard deviation of $289. It's the $1,043 difference in the mean earnings of the two groups we're interested in. Because the sample sizes in this experiment were so large, it's a safe bet that a difference this size is statistically significant. A confidence interval would give us a precise statement of the accuracy of our result. But before we can find a confidence interval or do a significance test, we need to think about the sampling distribution we'll be working with. We took two samples and found the difference between their means. If we took another pair of samples, we probably wouldn't get the same difference. In other words, the difference will vary from sample to sample. If we plotted those differences over many trials, we'd get the sampling distribution of the difference between the two means, x bar 1 minus x bar 2. It's this distribution that we're going to analyze. What we need to do is standardize this difference, get it into standard deviation units. To do this, we need the mean and standard deviation of the distribution. For that, we'll use the rules for means and variances we learned in previous programs. The mean of the distribution is simply the difference between the means of the two populations. The standard deviation is a bit more tricky. First, we'll find the variance of x bar 1 minus x bar 2. By the rule for combining variances, that equals this expression. To find the standard deviation, of course, we just take the square root. Now we have all the ingredients we need to standardize. As usual, we subtract the mean and divide by the standard deviation. Plugging the values we just calculated into the general formula for the z statistic, we get this somewhat ponderous expression for z. By substituting the sample standard deviation s for sigma in the z formula, we can produce the formula we need for the t statistic. This t statistic is the basis for the formulas we'll use to find confidence intervals and do significance tests. Let's see the t confidence interval that we'll use when dealing with two sample means. For comparison, here's the familiar formula for one mean. Now here's the formula for working with two means. You can see that instead of just x bar, we use the difference between the means x bar 1 and x bar 2. And instead of s over the square root of n, we use the expression we just developed for the standard deviation of the difference between two sample means. Now, we're not quite ready to find our confidence interval. When we worked with a single mean, finding the value of t star was easy. Just look it up in the table for the appropriate confidence level and degrees of freedom. But we hit a snag when we tried doing that for two sample means. You see, our modified t statistic doesn't exactly fit the family of t distributions. This problem is easily solved with a computer. But if you don't have a computer, you're not lost. Just use the t distribution with the degrees of freedom for the smaller of the two sample sizes. This will always give a conservative result, but it's better to err on the safe side. For example, if your two sample sizes were 13 and 19, you use the smaller sample size, 13. Since degrees of freedom are always one less than the sample size, you would look in the row for 12 degrees of freedom. Now let's go back and calculate a 95% confidence interval for the difference in earnings in the welfare experiment. To find the corresponding value for t star, we'll use the degrees of freedom for the smaller of the two sample sizes. In this case, that's 1,362, and that's off the scale of the t star table. In cases like this, we just use the last line of the table, which is labeled infinity. The t star value is 1.96. Now we can use our formula and table of values to plug in the numbers. 1.96 for t star, 6,595 for x bar 1, 7,638 for x bar 2, 247 for S1, and 289 for S2. Finally, 1,395 and 1,362 for N1 and N2. So our confidence interval is $1,043 plus or minus about $20. This means we're 95% confident that the true difference in earnings between the two populations is in the range of $1,023 to $1,063. This confidence interval is narrow. The estimated difference is very accurate, the result of the large sample sizes. The comparison shows that the options program almost certainly helps participants earn more money than participants in the standard welfare system. By the way, these results underestimate the impact of the program because the figures for mean earnings include some people who didn't complete the program at all and who didn't work. In many situations, we don't need a confidence interval. We simply need to determine if two means are significantly different. If you want to see how, just follow the bouncing ball.
Why is this ball bouncing? It's testing the performance of a new cushioning foam material, Ultracell. Union Carbide developed this foam to help solve an environmental problem of global proportions.
Conventional foams require a significant level of chlorofluorocarbons, or CFCs, in order to soften these foams. These act as blowing agents to lower the density, but also to lower the hardness of the foam, so they don't have such a boardy or rough feel. And of course, these have been implicated in the depletion of the ozone layer in our stratosphere and the subsequent concerns about the health related to that depletion.
Ultracell uses a new chemistry system to soften the foam without CFCs. Blending the secret formula produces, like magic, what appears to be an upstanding piece of foam. But will it feel like foam should? Comfortable to lie and sit on? Because a good night's sleep for millions rested on this question, Ultracell samples were pitted against standard foam in a battle of the bounce.
One of the keys to process improvement is to detect a difference, a meaningful difference between products. In the specific case of Ultracell, we are comparing Ultracell properties against the properties of conventional foam. That is, comparing averages against averages, using tests of significance, T-ratio tests, to judge which direction to move to improve the foam to bring it to its optimal combination.
The first of this barrage of comparisons is the critical support factor test, which judges how comfortable the human seat will feel while spending time on their foam seat.
Our support factor turned out to be 255, and that's very good compared to the 1.8 support factor we got on the conventional foam.
You want us to run some more tests on other foams?
By all means, let's go ahead to the rest of the series.
Okay.
Next in the series comes the combustion test. Conventional foam, then Ultracell foam. You may never have occasion to try this on your mattress, but just in case, the old foam stretch, the Ultracell stretch. The fatigue test simulates a lifetime of ups and downs for the foam in just a few hours. Finally, the more sedate bounce or resiliency test.
This gives you a feel for the surface springiness of the foam, which is a characteristic that many consumers like in a foam. In Ultracell, we generally get around 65% compared to maybe 50% for conventional foams. The utility of that kind of performance is that the foam will spring back to fill a cushion. If you're sitting on a cushion and get up, then the foam springs back to fill that cushion back up.
From the comparisons, it appears that Ultracell bounces back better, but it's up to the t-test to confirm whether performance differences are significant.
We measure the variation in each column of numbers, calculate a standard deviation that represents that variation, divide the difference of the averages by the standard deviation, corrected for the amount of data. If we find a large t-ratio, that testifies that there is a real difference between Ultracell and the standard foam.
So as Ultracell enters production, it promises to provide both an environmentally clean and a significantly smoother ride for the customer.
Let's do a significance test on the mean difference in resiliency scores to see how Union Carbide concluded that the new foam gives more bounce for the buck than the old foam. The sample size for the test of the old foam was 10, and the mean bounce score was 50. The new foam sample size was 13, with a mean score of 65. The standard deviation of both sets of scores was 2.5. As always, we begin our significance test by stating our null hypothesis, which is that the mean bounce scores of the two populations are the same. In other words, mu1 equals mu2. Since it's possible that the new foam could be either more or less bouncy than the old, our alternative hypothesis is two-sided. Mu1 is not equal to mu2. Now it's time to use that t-statistic we learned earlier. Since our null hypothesis is that mu1 equals mu2, we can set that part of the formula equal to 0 and forget about it. Then we can substitute numbers from our table. X bar 1 and X bar 2, the two standard deviations, and the two n's. The result is that t equals negative 14.27. We've had enough experience now to know that this result means there is clearly a significant difference between the old foam and the new foam. To get a precise answer, we need to find a p-value. So we go to our table of critical t-values and look for 14.27 in the row for 9 degrees of freedom. Remember that since we're not using a computer, we use the degrees of freedom for the smaller of the two sample sizes. Look at that. 14.27 is off the scale of the table. which means the p-value is below 0.0005. Because our test is two-sided, we double that and find a p-value below 0.001. We have found extremely strong evidence against the null hypothesis that the population means of the two foams are equal. The new foam is almost certainly better in the bounce department than the old foam. Sometimes it's quite helpful to examine both significance levels and confidence intervals. This is especially true in an area of research dear to all students' hearts, testing.
Any other questions, or should I go to the 10 SATs?
What three letters strike fear in the hearts of high school students? S-A-T.
Okay, when a set of T tennis balls was divided into C cans of B balls each, there was one ball left over. Which of the following equation describes the situation? So, Margaret.
This situation is best described as a hopeful equation for success on the Scholastic Aptitude Test. These students are enrolled in a commercial coaching class that's helping them to prepare for the SAT. High scores on the test are considered so important to a student's chances for college admissions that many spend good money and lots of time on coaching to boost their scores in a short period of time. The SAT consists of two 800-point sections, a verbal and a math. What's the total increase on the test that coaching students are shooting for?
100 points would help a lot.
I would say 150 points.
I sort of need about 200 points.
250.
But can coaching produce such large gains on a test that is supposed to measure general reasoning skills?
First, you're going to want to do what's inside of this box, all right?
The SAT is relatively resistant to coaching attempts. We have documented that coaching can have some impact on a test. The debate is over how much of an impact, I think.
So we -4. Now we're going to go
What
to the
improvements
next part
are
of the
coaching
book.
responsible for, and how significant are they, statistically and practically? Some claims are very significant.
Right, and that would be the answer to that problem.
Our average improvement is about 150 points. That's from prior score to post score. So the course, in a very short time, working pretty intensively, can raise scores a great deal.
So Margaret, what do you notice about this problem, first thing? What kind of answer choices do you have?
Variables?
Variables are what this issue is full of. Assessing coaching effectiveness with any certainty is difficult. Princeton Review backs its claims with a survey of students' self-reported scores. With the weaknesses surveys are vulnerable to, they are not very reliable indicators. There have been more carefully constructed studies on coaching effects, yet even their findings have been complicated by other variables.
And whatever works is it. It's that easy.
Investigators have studied different sorts of coaching programs that differ on such important characteristics as the length and duration of the programs. They've studied different types of students, and probably as important as anything, they've used different methods, different research methods to study the effects of coaching.
Studies have shown positive effects ranging from 15 to 50 points on each section of the test, with the margin of error on both the math and verbal scores at plus or minus 30 points. Most of these improvements are not statistically significant.
As far as practical significance, improvements on that order, 10 to 20, 25 points, it's extremely debatable as to how much of a practical effect that sort of improvement can have on one's chances of being admitted to college.
Once you hit certain levels, the college is basically going, all right, he has pretty good scores. Now let's look at the rest of them. On the other hand, the University of Texas, the University of California, they have cutoffs. The larger the school, basically, the more they just use cutoffs and straight SAT scores. If you got an 1190, you're out. 1200, you're in. What's a significant increase? 10 points.
All right, you're about to take the SAT. I'm going to hand out these booklets to you. Don't open them until I say so.
Either finding that SAT coaching is effective or is not effective will be bad news for many. If students aren't raising their scores appreciably through coaching, they've spent a lot of money and time for nothing.
So open your books to section 1 and begin. You have 30 minutes.
And if coaching is effective, that outcome has more serious implications.
If we can prove to you that the Princeton Review can raise SAT scores significantly in a short time, it means the SAT is not measuring any of the skills that it claims to measure, and that it may well be inappropriate for use as a college admissions test, as a financial aid test, as a scholarship test.
For now, though, the definitive answer still needs filling in.
We're going to examine one of these controversial coaching studies in a little more detail. The mean score for just the verbal portion of the test for the coached group was 460 with a standard deviation of 90. For the uncoached group, the mean score was 422 with a standard deviation of 96. With 95% confidence, our interval for the true difference is 38 plus or minus 53. So even though the coached group on average scored almost 40 points higher, computing the confidence interval gives us a different perspective. Taking the course could have a big impact, almost 100 points, or it could even have a negative impact. With the additional information of the confidence interval, a student might well reach a different decision on whether to take the coaching class. An interval that large also means our result isn't significant at the .05 level. That is 0, the point indicating no difference in the scores of the two groups, lies well within our 95% interval. In all our examples so far, we've assumed that the populations of the two groups were normally distributed. But even if they weren't normal, the t-test would have given roughly accurate results. That's because, just like the t-statistics for a single mean, the t-statistics for two means are robust. As long as there are no outliers and neither population is strongly skewed, the two-sample t-procedures aren't very affected by lack of normality unless the sample sizes are very small. We've focused on the mean in the past several programs, but of course, sometimes we're interested in comparing the variability of two populations. In other words, sometimes we want to compare standard deviations. There are simple procedures for doing this, but they have a big drawback that our two-sample t-tests do not. Standard deviations are very sensitive to the shape of the population distribution. If the populations are not very close to normal, these procedures can give wrong answers. It's wise to leave comparisons of standard deviations to experts. That's not to say that means are the only things we can analyze, though. In the next program, we'll learn how to perform inference on proportions, such as the proportions of men and women who pass my next exam.